In this video, I want to tackle the subject of casting. And I want to try to explain it to you in a way that you really understand it, because this can really confuse you and drive you nuts when you start to program. Now, in a different video, in an earlier video entitled Data Types, and then in another one called Built-in Data Types, we talked about how that when we create our variables, we have to tell C# what kind of data we're going to store there and really how much data, and we tell it that by telling it the data type to use, byte, integer, that sort of thing. Well, sometimes in our programs we have to take data from an integer data type and put it into a byte, or take data from a byte data type and put it into a variable that was created as an integer. And there's two types of moving this data back and forth between these data types. There's implicit casting, which means that this is a widening conversion. We're taking data from a less precise data type into a more precise. This will be done automatically by C# or by the compiler, because it knows if I'm taking a data that I can store, say, in a byte data type, and if you remember, a byte we can store, let me think a minute here, we can store anything from 0 to 255. So if I've got something stored in a byte data type and I try to then put that into an integer data type, well, the integer data type can store up to 2 billion, so I'm not going to have any problems putting the number between 0 and 255 into a data type that can store up to 2 billion, right? So there's no problem. It'll do it for me automatically. Here's where it gets interesting. An explicit cast is where we're doing a narrowing conversion. We've got data in an integer and we're trying to put it into a byte. Now, we could have a number of 1 billion and we're trying to put it into a data type that'll only hold up to 255. So we're going to lose some data. And so for us to explicitly program that kind of move between data types, we have to cast it. We're basically telling the compiler, look, I know this could be a problem, but I want you to do it anyway. Let me give you a picture here of what's going on in the background. When I move data between types, I can create some real interesting problems for myself. And what we're really getting into is the binary means of storage for these things. Now, here's a good example. If I've got data stored in a byte and I'm trying to move it to an integer, notice here I created a variable called d, and it's an integer data type, and I loaded it with the number 40, or I instantiated it at 40. Now, we know that the integer data type uses 4 bytes or 32 bits of data. And so this is what the number 40 looks like in 32-bit binary notation. I'm going to show you a little trick here. I don't know if you've seen this before, but I'm going to open the calculator. Okay, so if I go to All Programs, Accessories, and then open the calculator, I'm going to go to View and tell it to do Scientific. And I'm going to show you a little trick here. I don't know if you've seen this before. I hope so. Let me move this up here where you can see it. If I go to decimal and type 40 in and then click on bin, it shows me 1001000. So if I start from the right here, there's one. Well, it's not going to let me do that. But notice there's 1 space, 2 space, 3 space, 4, 5, 6. This actually goes out to 8 for a bit, right? I mean for a byte. So it'd be 8 bits. This is only using 6 bits. So notice 1001 is equal to the decimal number 40. I will just minimize the calculator for a moment. Now, if I set a byte equal to 40, not a problem, because the number 40 can easily be represented inside those 8 bits that make up a byte. And so we can easily move this number right here from a byte into an integer. No problem. We're not going to lose any data because they both fit. I hope you see that. But now let's talk about going from an int to a byte, which is narrowing. Now I've got a byte that is equal to 400. Well, and I've got an integer that I've got set at 400. I'm going to try to drop that into a byte and make my byte equal to 400. That's a better way of saying that. Now, my integer, if you'll notice, 400 takes 9 bits. It takes the 8 bits of a byte and then the first bit of the next byte. And if I look at this on the calculator, let me bring that up. I'll bring up my calculator, And if I do 400, you'll see that it's taking up 9 bits now. And so from here to the left is in that next set of bytes. So now, notice what happens. When I convert this from an integer down to a byte, what's going to happen here, the byte can't store from here over, so it drops this. So when I move this from here to here, from an integer to a byte, I'm going to lose all of this stuff. So let's go back to our calculator. What we ended up with was 10010000, okay? And let's convert that into English. So if I go to my binary, 1001, and I look at that as decimal, it's 144. So when I read it here as D, it was worth 400. When I insert it into a byte, it's now worth 144. So I'm not going to get 400 out of here. I'm going to get 144. Does that make sense? It's a little confusing, but that's the problem we get into. Now in part 2 of casting, I'll show you how to code this, and that's coming up next.